This is SpaceTime Series 29, Episode 81, for broadcast on the 8th of July 2026. Coming up on SpaceTime, how a passing star redirected comets to the inner solar system, a change in our map of the Milky Way galaxy, and evidence of vast hidden magma systems inside Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown how a passing star redirected a stream of comets from the distant Oort cloud to the inner solar system, consequently closer to Earth, and the cascade may not be over yet. The Oort cloud is a collection of comets, frozen worlds and icy debris orbiting in the dark outer reaches of our solar system and extending more than a light year deep into interstellar space. The clouds, thought to include leftover objects from the formation of our solar system 4.6 billion years ago, as well as interstellar objects that are tagging along after being captured by the Sun's gravitational field. About 2.47 billion years ago, a spectral Type G yellow dwarf star, similar to and about 1.07 times the mass of our Sun, which is catalogued as HD 7977, passed close to our solar system. But exactly how close is still a bit of a mystery. Today, HD 7977 is located in the constellation Cassiopeia, about 246.9 light-years away. But during its close encounter with our solar system, calculations based on observations by the Gaia spacecraft suggest that it may have passed within the Oort cloud, coming to within 0.064 and 0.4 light-years from the Sun. Now, by comparison, the nearest star to us today is Proxima Centauri, which is 4.25 light-years away, which makes it 8 or more times further than this closest approach. Now, this new study by Nathan Cabe from the Planetary Science Institute and Sean Raymond from the University of Bordeaux have further refined those distances, suggesting that HD 7977's close encounter with our solar system could have been as near as 0.095 to 0.185 light-years from the Sun. Now, at its nearest, that means it was just 6,000 times further away from the Sun than what the Earth is. Their research, which has been presented at the American Astronomical Society Division of Dynamical Astronomy, suggests that the gravitational perturbations triggered by such an encounter would have altered the orbits of some of the Oort cloud objects, sending them cascading into the inner solar system, in other words, where the Earth is. And they believe that we may still be feeling the effects of that passage today. The European Space Agency's Gaia mission was a telescope that precisely measured the changing positions and brightnesses of thousands of stars and other objects in our galaxy relative to background quasars and galaxies. Its combination of a spectrograph to measure motions towards and away from us and its high-resolution cameras to measure proper motion across the sky has allowed three-dimensional motions to be calculated for roughly 1% of the objects in our galaxy, including the star HD 7977. It allowed astronomers to understand the history of our solar system in new ways. Normally, the gravity of the galaxy's outer disk is the primary force causing icy objects in our solar system to change their orbits. This pull spreads out what was once a disk of material into what researchers calculate is currently a spherical shell of objects. This shell, the Oort cloud, is named after its discoverer Jan Oort. And this same galactic tug should also dominate the orbits of new comets entering our solar system for the first time. And once it enters the solar system, the effects of the planets and its passage near the Sun can radically change a comet's orbit, and these forces should leave a distinct signature in the direction that a comet orbits relative to our Milky Way's midplane. Now, if HD 7977 passed as near as Cabe and Raymond propose, its gravitational influence would temporarily dwarf that of the galaxy, and the galactic signature should be absent from current comet orbits. And that's exactly what Cabe and Raymond found when they analysed the orbits of several new comets. Cabe says the distribution of comet orbits suggests that we're living through an unusual time where HD 7977 has dominated the generation of new comets and not the larger gravitational field of the Milky Way as it usually would. This would also mean that we're living through the late stages of a pretty rare, powerful cometary shower. Now, to test this idea, Cabe and Raymond ran a series of computer simulations to understand what comets would look like as a result of HD 7977 passing at different distances. The computer models were then compared to the passage of 112 long-period comets that have been observed since 1989, when professional surveys first made it possible to detect new comets in both hemispheres. By the way, long-period comets are identified because they have highly elliptical orbits that typically take thousands to millions of years to complete. Brand new comets, on their first passage to the inner solar system, have orbital periods measured in millions of years, while older comets, on subsequent visits, have much shorter periods due to their prior interactions with the planets and the Sun. The authors found the observed orbits of comets on their first passage into our solar system's inner regions matched HD 7977, triggering a wave of long-period comets to enter our solar system. Older comets on repeated passages are consistent with the galactic disk pulling and creating their orbits. The authors say their predictions will be tested in the next 6 to 12 months. That's when the next data drop from Gaia is released. This is SpaceTime. Still to come, changing our map of the Milky Way galaxy and evidence of vast hidden magma systems deep below the surface of the red planet Mars. All that and more still to come on SpaceTime. Astronomers have redrawn our map of the Milky Way galaxy, moving its outer arms up to 10% further away than previous estimates. The revised picture is based on new data from both NASA's Chandra and the European Space Agency's XMM Newton X-ray space telescopes. They were observing the aftermath of 3 bright explosions thrown out by 3 separate gamma-ray bursts, echoing through the outer spiral of the Milky Way galaxy. By measuring the distance to these echoes, astronomers were able to refine the distance to the outer arms. The thing is, we really don't know much about the structure of our galaxy's outer regions. That's because it's like looking at the forest through the trees. It's difficult to observe our galaxy from the inside. The solar system is well embedded inside its disk, preventing a bird's eye view, and as well as that, many regions are obscured by thick clouds of cosmic dust. But by using data from ESA's Gaia Space Telescope, it's allowed astronomers to gain a better perspective for mapping the Milky Way, doing so in more detail than ever before by measuring more precise distances to its stars. Before Gaia, astronomers weren't even sure if our galaxy had 2 or 4 spiral arms. We now know there are 4. Beatrice Vair from Italy's National Institute of Astrophysics says now another of ESA's missions has found a new way to map the extremities of our galaxy. Vair says astronomers usually model the Milky Way's outer arms indirectly based on what we know about how our galaxy rotates. But doing this leaves room for error. So instead she looked at the aftermath of 3 cosmic explosions that took place far away in more distant galaxies. These explosions flung out X-rays that echoed through several of the Milky Way's outer arms, and she measured the distances to these echoes directly. The X-rays bounced around and were scattered by dust grains within the Milky Way spiral arms, forming bright rings that were then picked up by the XMM Newton and Chandra space telescopes. By studying how these ring-shaped echoes slowly expanded over time, Vair and colleagues were able to pinpoint the distance to the scattering dust grains. As these grains lie within clouds within the arms of the galaxy, the authors were able to directly measure the distance to those arms. Besides confirming the known distance of the Perseus arm, the authors also found that 2 of the Milky Way galaxy's arms, the outer Scutum Centaurus arm and the outer arm, are located up to 10% further away than previously thought. This is SpaceTime. Still to come, evidence of vast hidden magma systems inside the red planet Mars. And later in the science report, a new study finds that your mental health might well be impacted by the mental health of the people you went to school with. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Incogni. If you're anything like me, you're probably concerned about your privacy online. And for good reason. Did you know there are hundreds of data brokers out there quietly collecting, buying and selling your personal information? Now, I'm talking about your phone number, your home address, your browsing habits, even your location history. And that's where Incogni comes in. Incogni is a service that acts on your behalf, requesting the removal of your personal data from these shady data brokers. And they don't just send a one-off email. They follow up, track responses, and ensure that your data actually does get deleted. Think of it as having a digital privacy agency constantly working for you behind the scenes. And the best part, it's all incredibly easy. You just sign up, give them the go-ahead, and Incogni take care of all the rest. And within just a few weeks, you'll start seeing the results. There'll be fewer spam calls, less targeted advertising, and a genuine sense of relief knowing that your private data is no longer being traded like a commodity. Now, as a SpaceTime listener, we're offering you a special discount deal. Just go to incogni.com/Stuart Gary. That's incogni.com/Stuart Gary. And if you're not completely satisfied, no worries. Incogni offers a 30-day money-back guarantee, so you can try it out risk-free. You know, protecting your privacy really shouldn't be optional in this digital age. So let Incogni help you by keeping your personal information where it belongs, with you. That's incogni.com/Stuart Gary to access this exclusive discount offer and learn more. Stay safe, stay private with Incogni. A new study has uncovered that the red planet Mars once hosted enormous Earth-like magmatic systems deep beneath its surface. That's despite the planet lacking any plate tectonics, which was long thought necessary for this kind of geological complexity. The findings, reported in the journal Nature Astronomy, reveal fascinating new possibilities for how rocky planets could become habitable. Mars is often described as a stagnant lid planet. Unlike the Earth, its surface is not broken up into moving tectonic plates. Because plate tectonics drives volcanism, recycling and continent building on Earth, many scientists assumed Mars lacked the conditions needed to produce similarly complex crust. However, this new study challenges that view, suggesting that Mars could have produced highly evolved crust through intense internal recycling. The findings are based on data recorded by NASA's 2018 InSight lander mission to the surface of the red planet. InSight investigated seismic waves from meteoroid impacts and Marsquakes, the Martian equivalent of earthquakes. The authors used that data to investigate a mysterious boundary layer about 24 kilometres beneath the Martian surface. Now, previous studies had identified this boundary, but no one knew what it really represented. To test the idea that this boundary may have marked a transition between two different rock types, the authors compared hundreds of possible rock compositions with the seismic data using thermodynamic modelling and statistical techniques. They found that while rocks above the 24-kilometre boundary appear to be mafic, that is, they contain high proportions of silica, rocks below the boundary seem to be ultramafic, which means they're rich in iron and magma, but low in silica. The authors suggest this buried layer would have formed where molten rock pooled deep underground and gradually separated into two distinct materials. This would leave behind a thick residue of dense crystals at the base of the crust, while lighter, more evolved melts rose upwards. On Earth, similar processes occur beneath volcanic arcs and are linked to the formation of the continents. The study's lead author, Tobamori Maki-Champion from Oxford University, says scientists have traditionally assumed that volcanism on Mars was relatively simple compared to that on the Earth. But this new discovery suggests Mars could sustain large, long-lived systems where molten rock evolved and reprocessed itself throughout the entire crust. The study suggests that this layer may extend sideways for hundreds, even thousands of kilometres around the northern Martian hemisphere, indicating that the red planet once hosted enormous interconnected magmatic systems rather than simple isolated volcanoes. This phenomenon, known as transcrustal magmatism, was previously thought to be unique to Earth. These geological processes are closely linked to how planets develop atmospheres, oceans, and potentially habitable environments. For instance, here on Earth, geological recycling helps regulate climate and supports long-term cycling of water and other volatile elements. Scientists have often assumed plate tectonics were essential for creating these conditions. But the new findings suggest planets may not need Earth-style tectonics to build complex crusts or sustain the conditions that support life. One of the big questions in science has always been whether planet Earth is unique. If Mars could develop this kind of complex crust without plate tectonics, then maybe the conditions needed for habitability could have emerged on more planets than just Earth, including those previously dismissed based on their size or their apparent lack of tectonic activity. It's all just another part of the amazing treasure trove of data coming from NASA's InSight mission on the Elysium Planitia region of the Red Planet. This report on InSight from NASA TV.
Touchdown confirmed.
InSight has been fantastically successful. We've gotten more science than we had ever dreamed that we would get during the course of this mission. InSight's primary goal was to better understand how the terrestrial planets, the rocky planets, formed and evolved.
First, we landed an incredibly sensitive seismometer on the surface of Mars, and with that, we were able to record over 1,300 Mars quakes.
And these range all the way from tiny little tremblers that just barely go over the noise background to a handful of quakes that were larger than magnitude 4.
And feeling those vibrations, the scientists can actually take that information and use that to reconstruct all the material that those Mars quakes traveled through and thereby see the interior of the planet.
We looked at its core, which is big and not very dense. We looked at its mantle, which is not so hot. And we looked at its crust, which is not too thick and not too dense compared to some of our pre-mission expectations.
By measuring the detailed structure of the inside of Mars, it gives us a snapshot of what the planet looked like 4.5 billion years ago. The other thing that we've been able to do is make a very detailed record of the weather at Mars. So we have a really good weather station, which has allowed meteorologists to study the weather at the InSight landing site and relate that to the climate changes on Mars.
What we didn't do, unfortunately, was make the heat flow measurement we wanted to make. Our heat flow probe was supposed to get 3 to 5 meters down, and we were unable to reach that depth.
But we were able to get some of those measurements, such as the heat transfer amongst the soil.
It's left a permanent mark on me. I literally tattooed InSight onto my arm. I'll never let it go.
We've really rewritten sort of the chapter of the encyclopedia on the interior of Mars. That was our last big hole in our understanding of the planet.
There's a lot of data that people are going to be looking at for decades to come.
We accomplished so many of our science goals, and we're going to have something to look back on and be proud.
And in that report from NASA TV, we heard from InSight Principal Investigator Bruce Bannert, InSight Project Scientist Mark Panning, and InSight Deputy Project Manager Kathia Zamora Garcia. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study in Finland has shown that the mental health of your high school mates may impact your own mental health. The findings, reported in the Journal of the American Medical Association, indicate that people who had high school peers with a genetic predisposition for mental health disorders or a diagnosis of a mental health disorder were also at an increased risk of being diagnosed with a mental health disorder themselves. The authors say having peers with diagnosed depression or anxiety may make teens more aware of symptoms, reduce stigma, and encourage them to seek treatment. A large new study of over 120,000 kids has found no link between paracetamol use during pregnancy and the risk of autism or ADHD. The study, published in the Journal of the American Medical Association, compared pairs of siblings to try and remove genetics and family environment from the equation, because both HDAD and autism have a strong inherited component. The authors found no link between paracetamol use in pregnancy and increased risk of either autism or ADHD, regardless of the timing, pattern, or dose of paracetamol use. A detailed study of a fossilized 113 million-year-old pterosaur wing has found it was so well preserved in 3 dimensions that it even retained chemical traces hinting at its diet. The findings, reported in the journal iScience, suggest the ancient flying reptile, which lived during the age of dinosaurs, had a diet rich in fish and squid. The authors were able to make that determination thanks to traces of steroids preserved in the remains, an unusual mix of special bacteria, and a unique ancient marine environment preserving not just the structure, but even the subtle chemical traces of the animal's biology. The discovery highlights the growing potential for molecular paleontology to unlock secrets from deep time. Scientists have found a new way to control quantum light sources, which is one of the key elements needed before quantum technologies can be used reliably in the real world. The research reported in the journal Science Advances brings scientists a step closer to being used in practical quantum computing, secure communications, and ultra-high-resolution sensing. The authors from the University of Technology Sydney say they were able to significantly shift the colour and wavelength of the light emitted. Unlike many experiments, where a device is made at one twist angle and left alone, the authors were able to pick up, twist and restack hexagonal boron nitride repeatedly and use that twist to modify the emitters, which you can't do with traditional materials like diamond or silicon carbide. These materials could eventually be used for applications such as healthcare, cybersecurity, and improved GPS, and give more control over the building blocks needed to get there. Beta testers are continuing to play around with Apple's new Siri AI ahead of this month's public beta launch. Among those testing the new Google Gemini-based artificial intelligence is technology editor Alex Zaharov-Reutt from TechAdvice.life.
At the Worldwide Developer Conference, Apple announced its long-awaited upgrade to Siri. So it's now called Siri AI. And although it's using the Gemini brains from Google, it's not just a plug-in. Apple's been training its own models with Google's models, and they have a lot of, where they can, on-device work and the private cloud compute work to make sure that your queries and as much of your activity remains as private as possible. And this has given Apple, the AI, the ability to have natural conversations, the same sort of things we see with Gemini and ChatGPT. It can now edit photos in a much more performant way. It can rewrite things more effectively. It has real-world knowledge. And look, at the moment, it's only available to beta testers, and we just have the first and second developer betas. There will be a public beta sometime in July, and the whole thing will be ready for the public in September when the new iPhones also launch. So unless you're a real tech head and you've got spare iPhones, I wouldn't be updating your primary device to these beta versions. Even when the public beta comes out, it's always a bit of a gamble as to whether you should, because the beta version can have bugs. Now, people have said these latest betas are very smooth, but you go to Reddit and you read the iOS beta forum, and the litany of beta problems that people have every year when this happens are there for all to see. So not recommended for the general public, but all the app developers and people with spare iPhones that love tinkering, they're well into it.
That's Alex Zaharov-Reutt from TechAdvice.life, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.